Okay, excellent. So thanks, Grant, and thank you for the invitation. It does feel a bit strange to be, how can I say this? Strange to be in familiar surroundings, but it is quite something. I'm obviously very familiar with the place, very familiar with being here at this lectern, which I believe was made in the 1980s by somebody in this room. And it is actually nice to be back and to recognize Sharma, a lot of the old faces. Yeah. So I was hoping to see more new faces, but there's a lot of old faces here. So when I was asked to give the presentation, it just occurred to me that I have been at this place before. The first time I actually stood here to give a presentation was in 1994 when I was here on sabbatical, and Tim came into my office one Monday morning and said, we want you to give the Friday seminar. I'm being kind to him because I think it might have been the Thursday morning, but nevertheless. So, yeah, 1994, 18th of March, I gave a presentation here as part of a Friday seminar the first time. And then in 2005, I gave another Friday seminar about our flotation work. And now we're in 2016, and here I am again. Those of you who are mathematically inclined will see a linear progression from 94 to 2005, 2016. So if I'm still around in 2027, I'll be waiting for the invitation. Where did I get the title from? Well, Remembrance of Things Past. I retired at the end of 2014, and one of the things that I've had a chance to do is to think and to reflect, which is quite a fun thing to do, actually. And it's something that people don't often do, and especially if you're running around working, flat out all the time, you don't often stop and think. And M. Scott Peck in The Road Less Traveled says one of the major dilemmas that we have both as individuals and society is simplistic thinking, or the failure to think at all. And it's not just a problem, it's the problem. So I started thinking, and one of the things I thought about was this old Greek guy. Now that is not me. That's me, if you can believe it. That's me in 1978 on the Greek island of Rhodes, which is over there. This old fellow used to live in Salakos, which, if I can work this thing, Salakos is, can I do this? Over there. Okay. And I heard about this chap. He was 100 years old. And the most remarkable thing about this chap was that in his lifetime of 100 years, he had seen transport go from donkey to seeing a person on the moon, which is phenomenal for a 100-year existence. And he used to take, in his youth, he used to take, they used to grow olives and things there, and then he'd take them to Rhodes on his donkey. It'd take 2 days. Well, now it's 38 kilometers, you do it in 40 minutes. So I was thinking to myself, what changes have I seen in the time that I've been around? And I don't know if it's interesting or not, but it was interesting to me, so I'll share it with you. So in my life, 1951 to the present, I've seen the world population go from 2.5 million to about 7.5 million, which is a threefold increase. Why that's special is that I don't think the young people in this room will ever see that in their lifetimes. In fact, if you were born in 1804, when the population was 1 billion, you'd have to live 156 years to see the population treble. If you were born in 1927 and it was 2 billion, you'd have to wait 72 years to see it treble. I've seen it treble in my lifetime. I'm not 65 yet. Anybody born now, you are no chance. I don't believe that. So it's just quite special. Fast forward to 1972. This is when I graduated as chemical engineering, University of Cape Town. And you can see that things were quite different then. First of all, they hadn't invented women. It was chemical engineers in those days were all males, and we were all in black and white, which is quite amazing. And the professors seemed very old in those days. Fast forward again to 1984, when I was back as a lecturer, and now you can see that fortunately the other gender has been invented, and also we've invented color, which is great. This lady over here, who was a postgrad student in those days, Alison, she's now the Dean of Engineering at UCT, and that's how things change and things happen. Some of you may recognize Cyril O'Connor, Bill Randall, and Martin Harris, who was a postgrad, my postgrad at the time. So there you go. Fast forward again another 30 odd years, and it's terrible what the ravages of time have done to this poor fellow. But now we have, as you can see, this is post-apartheid. We have a large number of students of all sorts of shapes and sizes, and we have women on the staff. And in fact, there's only 3 ladies on the staff shown in this picture. I think it's now up to about 5. So things have changed. Just in context, I wasn't in Australia at the time, so just to put 1972, the year I graduated, into context, that was the year when the Aboriginal tent embassy was constructed at Old Parliament House in Canberra. It was the year that Gough Whitlam became Prime Minister. Can you believe it? It was the first aircraft hijacking in Australia that year. Ansett Airlines, anybody remember Ansett Airlines? Shane Gould was Australian of the Year. JK celebrated its 2nd birthday, and you were still 2 years away to the Great Brisbane Flood of '74. Okay, so what's changed since I was a student? I haven't got my little piece of paper here that tells me how I'm doing, because I've got about 700 slides here. And I need to hurry up. So, okay, 7 minutes and I'm 8 minutes, not too bad. Okay, so what's changed since I was a student? Well, when I was a student, my first lecture was how to use a slide rule. We also used log tables. The following year, we learned Fortran programming. We used punch cards. We used a mainframe computer. A year later, the HP calculator came in, $395 for an HP 35. I've never used a slide rule again. I've never seen one again, actually, except for mine. I don't know if anybody's heard of a Hermes. John Pilger wrote a wonderful essay on baby Hermes. He talked about his typewriter. There's Hermes typewriters. I typed my final year thesis on a manual typewriter. A couple of years later, my master's thesis was typed on an IBM golf ball. I haven't seen those for years and years and years. I printed my PhD on a daisy wheel printer. Since then, we've had dot matrix printers, laser printers. A lot of those other technologies have just become obsolete. And now, I get this through my door. At Aldi, I can go to Aldi and buy a 3D printer for $499, where I can make these fascinating little gizmos over here, whatever. But, you know, people have used 3D printers to make motor cars. So it's unreal what's changed. In 1982, when I was at the Open University, I typed my thesis on a terminal connected to the mainframe at Cambridge. We were still using mainframes. 1982. 83, I was one of 3 people to test the IBM personal computer. Personal computing came in. 1984, one of my colleagues, who will remember Jeff Hansford, he acquired an IBM portable computer. This was fantastic. It only weighed 30 pounds. It killed you getting it in and out of the car, but it was fantastic. It had this little screen about this size, which was with either yellow or orange writing. Now my laptop weighs less than 2 kilos. I put it into my briefcase, I don't even feel it. And I don't know if this quote is true, but it's too good not to be true. The 4th generation iPad has got more computing power than the world's most powerful supercomputer of 30 years ago. And it's just amazing. Data storage. We used to have things called floppy disks, 256 kilobytes. We moved to something which we used to call stiffies. I don't know whether you call them that here, 1.4 megs. I think this is a 64 meg, no, is it gig or meg? Gig, 64 gig USB I've got here. And at home, I mean, you can buy 2 terabyte hard drives. And you don't even need hardware. You can put something on the cloud. It just like disappears off your screen. You go anywhere in the world, you'll find it again. I mean, this is unreal. In 1970, gold was $35 an ounce. Oil was $3 a barrel. And again, Jeff Hansford, who was lecturing us solid fluids operations, came back from the first South African Institute of Chemical Engineers conference so excited that milling had been modeled as a chemical reaction. Now, I know that if I show this, I should probably have security people come and take me away. Nevertheless, this was quite amazing. So, gold from $3, from $35 an ounce, look how it stayed constant all that time. And then, bingo, it's taken off. I believe today it's around about 1,200. At the same time, gold production And the important thing about this is that I was looking at South Africa at the time. South Africa, as you can see, was miles ahead of anybody else in terms of gold production, which basically kept that country and the nationalist government in power for all those years. And since 1970, it's taken a massive dive. So just because I left university, look what happened. The oil price, again, the oil price, which was $3 a barrel and had been that forever and ever. We had the Iran crisis of 1973, and again, the oil price just took off, obviously with all its geopolitical implications for the Middle East and for the world economy, and I believe now it's hovering around 50, but it has been, as we know, up to 150. Just in terms of making predictions about the future, I don't know how many of you will remember being in this very room where one of my former students announced, I don't know, about 5, 6, 7, 8 years ago, that the oil price would never fall below $150 again. So I want us to be very careful about saying anything about the future. The other thing is, so in terms of Comminution modeling, does anybody still use the chemical reactor model? I believe everybody now uses the JKMRC. In 1970, if I wanted to phone my girlfriend, I had to book the call on a telephone exchange at a pre-booked time and be connected. Nowadays, there are 4.8 billion mobile phones around the world, and Skype is for free, which is just unreal. If you wanted to go anywhere, you bought a map. Nowadays, you're guided by satellites flying around the world on your mobile phone. There's the JK. I spent, I don't know how long when I did my PhD, sitting in the library pouring through chemical abstracts to find references. I mean, nowadays, you can get as much information as you want, anywhere you want, all those different search engines. YouTube apparently is the second biggest search engine in the world. It's the information age. I mean, information is out there. And finally, bank deposits used to be made into a little deposit book. I remember when I went to England to do my PhD, we still had to go into the bank in person with the deposit book to have them enter the amount of money into your book by hand. And once a year, they took the little book in and checked up that all the numbers were in fact correct. They did an audit. I mean, now I don't do this because I don't dare. My daughter does this all the time. She pays accounts on her mobile phone. So a tremendous amount has changed since 1970. The quote from Arthur C. Clarke, "New technologically shaped realities will be indistinguishable from magic." If you told me in 1970 that I'd be using a telephone and see the person on the other side, I would have told you to get lost, because that was obviously nonsense. It had to be rubbish. What about the mining industry? What changes have we seen there in the last 45 years? Briefly, my history of the mining industry. Obviously, I don't have to introduce myself to you because most of you know me already. I had an undergraduate scholarship with Anglo American, followed by a master's bursary with Mintech. Then I worked for a few years with Anglo and De Beers and Anglo Coal, and then I went back to academia. I was in UCT for 13 years. I was here for 10, and then back again at UCT for another 8 years. So my harsh reality, my first lecture was Velcom Gold Mines. I was told by the chief engineer, "What are you doing here? We don't need chemical engineers in mining," which is, a bit of a shock to the system. My Mintech postgrad bursary was done in Ion Exchange, which is a very, very common unit operation. And then after graduation, I was posted to Western Deep Levels Gold Mine, the biggest gold mine in the world, where they were still doing hand sorting in those days. They had, if I remember, 5 ball mills, 32 tube mills, little things running, the whole building full of these little things running. And then I was posted to the Diamond Research Lab, and I met this gentleman whom 40 years later, we still know each other. And then finally to Cullinan Diamond Mine, where I came across the X-ray sorter. I don't know whether that was what found the Premier Rose diamond a couple of years later, but it was this big thing, big building, whole building that just stood waiting for this big diamond to come along. The other thing at Cullinan Diamond Mine, I did battle with a thickener, which contained this material that was supposed to go to the slime slam that just would not settle. And I have memories of doing night shift with a chap called Graham Miller and Neil Holloway, trying to get this thing to work, doing flocculation tests. I was then posted as senior plant met to Namibia, to Remembrance over there. And I did some time in the sort house, which was wonderful to actually see diamonds, lots of diamonds. It was also my first experience with open cut mining, and to be working in the mines at the beach was just absolutely fantastic. So this is my first experience, I said, with these big trucks, haulage trucks. 78, I spent 9 months with the Anglo Coal Division, which is where I got to know my mentor, David Horsfall. I worked in the area of fines and ultrafines, not realizing that's a project I did for him, not realizing that would occupy me for about the next 15 years and longer. And interesting, my brush with industry at that point, I reckon in 6 months I did enough work there to get an MSc, as opposed to having to spend 2.5 years at a university. That's how things work. This is me, believe it or not. After that, I spent a gap year in Rhodes, and then 3 years in England, where I got a PhD and 2 daughters. Rose told me at that point that I should mention the fact that I had a wife. And then I went back to University of Cape Town after that. There may be an offer I couldn't refuse. I went back as a lecturer, where the first thing that they did was ask me to lecture the mineral processing course, which I took over from this gentleman here, whom some of you may recognize as Barry Wills. I was involved in vacation training and straight back to the thickener at Premier, which they still hadn't sorted out. We started something called the Western Cape Mineral Processing Facility, which was a grouping, a collaboration between the 3 local universities in mineral processing. And the first 2 chaps that we hired as technical officers were Dave Deglon, who now runs the Centre for Minerals Research at UCT, and a fellow called Francis Peterson at the University of Stellenbosch, who is now Deputy Vice Chancellor at UCT. As I said, in my research, I was involved in confirmation. With Cyril, I became involved in cells, and then the last thing is we got involved together with developing the bubble sizer, which is what brought me to the JK in 1994 on sabbatical. Was a great year. We obviously the bubble sizer a lot. We developed the KSB model with Barun Garain. He measured, I think, about 1 million bubbles, which would have been, he'd still be doing it if he was trying to do it with a ruler. And being on sabbatical, I obviously did the opportunity to do other things like go to Tasmania, visit Mount Isa, and then do a bit of snorkeling, which is rather nice, as people do. But one thing did lead to another, and in 95, the next year, David Stribley from Amara came over to South Africa in August, gave a presentation about P9 at the annual conference. Tim came over in October. We had a meeting with the platinum producers in Joburg, and P9L began in 96 with 3 South African sponsors. Later that same year, I came over here, and I took over from Steve Morrell, ran P9L and P9M, up to 38 sponsors. In our area, in flotation, we worked in floatability, froth recovery, we developed JK Simfloat, and we introduced Comminution at UCT, which is when we invented Malcolm Powell. And obviously great collaboration between JK and the UCT, but also extended to McGill, Hachatepe, Newcastle, and Rio de Janeiro. And just a couple of pictures. The redoubtable Sergio, this campaign with Perti and other people at Cambalda, Craig Sweet, and then this is the gang of 3 plus 2. I think this is Orivaldo getting the prize for his research presentation, I think Student Research Day. A bunch of us going off to the OSIMM Operators Conference in Papua New Guinea. This is the 3 cubic meter cell, Emmy, and some students at the time. Cooperation with CSIRO, Barry again. This is Zafir from Hachatepe. A couple of us at the 1997 Barry Wills Conference in Santiago in Chile. Brian Jameson, with whom we collaborated, Cesar Gomez, and other people you may recognize. Frank, I think, is in the audience. Frank, there you go. I think this is in Phoenix, one of our roadshows. This is Emmy with some JK graduates, also part of the roadshow. This is us trying to persuade Newmont to join the program, and that's the FCTR, which is some of you took up a big part of our lives. We collaborated with industry. These are some sponsor meetings. And we won some awards, which was rather nice. Kim, I don't know if you remember this. Kim appeared in the Courier Mail in a cartoon as, I think, the Woman Scientist of the Year. So I had a good time. But there's more to mining than technology, as I think you're well aware. And if my memory serves me right, Tim and Don did a bit of a roadshow, speaking to a lot of CEOs of all the big mining companies, where sustainability was like a very big thing. And the SMI was born. Sustainable development is very much a key thing. And on the right-hand side, Sir Paul Collier at the Mining for Development Conference in 2013, which to me was one of the best conferences I've ever been to. And this is remarks from the CMM. The focus in talking about sustainable development, the focus is not on how mining can be sustainable, because obviously any individual mining operation is a finite life, but on how mining minerals and metals can contribute to sustainable development. And so in 2007, I went back to UCT to start the Minerals to Metals initiative, where we did two kinds of projects. Fundamental research projects, which were very much scientific, basically at the interface between the unit operations, things like rheology, mineralogy, and then so as to try and improve the going from one step to the other. And then systemic project, which was more like stand back from the process, try and improve the whole process, minimize overall waste production, energy consumption, water consumption, and cleaner processing options. And that's what I was at UCT for the last period of my career. We involved the Center for Minerals, were involved, Center for Bioprocess Engineering, the Allison for Crystallization and Precipitation, Harrow Environmental and Process Systems. These were all groups in ChemEng that came together in the Minerals to Metals group. We also involved Dr. Divine Few, Department of Social Anthropology. We involved lecturers from Commerce, Energy Research Center. Some of you will remember Andy and Inderson from Department of Physics. And Dee Bradshaw, who took over from me at the beginning of this year in my chair, has actually taken this even to a further new level. Only last Friday, the 27th of May, she participated in this launch of a new chair in mineral law in Africa at UCT, Mining and Waste, where, as you can see, the mineral law chair teams up with the Minerals to Metals initiative in ChemEng, Prof. Dee Bradshaw, Saatchi Chair for Minerals Beneficiation. Interestingly, the collaboration also engages the Center for Curating the Archive at the Michaelis School of Fine Art and scholars from the Economics and Humanities Faculty. And the day ended with an art exhibition where on Stygian darkness, destruction and detritus in the South African mining industry, were addressed by the Vice Chancellor of the University, who participated in the seminar all day with two Vice Chancellors. So Dee's doing great stuff at UCT. To me, the best thing that came out of that time, or out of that group, was the master's degree. We developed a new master's degree program in sustainable mineral resource development, together with the University of Zambia, where students come together 4 times a year to do a course: Introduction to Sustainable Development in Stellenbosch, Strategic Social Engagement Practice at the Business School in Cape Town, Environmental Stewardship in Mining and Minerals in Zambia, and the research methodology which they do at UCT, followed by an internship and a master's dissertation, which has 2/3 of the credits. The philosophy, rather like an MBA, is to integrate all disciplines into one program. The students have to be from different backgrounds, because then they can actually have something to give to each other. There's real-life case studies, problems that they bring, current problems that they bring to the group. Strong emphasis on environmental and socio-economic issues. The most remarkable thing about this group, and I've been involved with 2 cohorts so far, is that after a year, this disparate group is talking the same language in terms of sustainability in the mining industry. And it's fantastic. It really is just brilliant how they learn from each other, how initially they can be fighting madly with each other, but there's a meeting of minds. The first 2 cohorts in 2014 and 2015, the 32 students, 17 at UCT, 15 in Zambia, with first qualifications in chemical mining, civil and mineral processing engineering. And then there were 3 foresters. We had 1 person for geography, a couple of geologists, social anthropologists, social science, psychology, law, business science, economics. So all of those involved in mining. This is quite phenomenal. 19 males, 13 female, aged from 21 to 51. A picture of the first cohort. This picture is taken in Zambia, in Lusaka. Jenny Broadhurst over there. She and one of the big people, one of the big motivating driving forces in this endeavour. Some of you may recognise Mark Jones from Sydney, who came all the way to South Africa to do the course. And this is last year's cohort. Jenny again, Harrow, Sue also involved. And again, I don't know if anybody of you know Andrew Keith, who lives just down the road in Brisbane. He's part of this course, and he also done the courses in South Africa, flies over to do the courses. Just some of the dissertation topics that these students have been doing. We've had three graduates so far. One of them is a social anthropologist whose thesis is on youth entrepreneurship in the context of minerals. He's graduating next week with a distinction. The lawyers, legal frameworks for encouraging sustainable communities after mining, sustainable use of water in the copper mining industry, that would be an engineer, and then the use of geographic information systems and remote sensing to measure the impact on forest cover chains. That was one of the forestry students. And yes, I should have been drinking my water while I did this. So this is what I've been doing since the beginning of last year, which, as I said, is fabulous. I'm enjoying it. I do still keep involved, obviously. I've been doing things like editing theses and papers and things, but basically in my own time, and well, I'm loving it, and I just hope it lasts for a while. Please listen. So, a terrific amount has changed since 1970. 25, that's fine, about 5 minutes. Comminution, obviously, from those little tube mills, we're now up to, I believe, 42 feet, 28 megawatts. SAG mills. SAG mills weren't invented, I think, back then, and they've something completely new. Hybrid grinding rolls, iron mills, in flotation. You know, we have these, nowadays, we have these ginormous tank cells, which is something we never had before. I don't know whether they've got the 600 cubic meter unit yet, but that's where it's going. Column cells, James cells, bioleaching. Who would have thought that I would write a paper with a microbiologist? And yet I have. I mean, we supervise a student together. One of our best students, in fact, I think got 9 papers out of his thesis. Fabulous stuff. So it was myself, Sue, microbiologist, Aubrey, and Jochen. I mean, you know, it's just fabulous, really good. Gravity concentration. Well, I still remember the Aikens classifier back at Western Deep Levels, taking forever and ever. Nowadays we have Nelsons, we have Falcons, we have the reflux classifier. Is a lot different. I think one of the biggest changes has been in the area of process mineralogy, where in fact the JK developed the mineral liberation analyzer, which led to things like geometallurgy. You know, being able to mine smarter and predict what will happen when the stuff gets to the plant. Tomography, really big thing. You can look inside a particle and see the minerals. These are all static measurements. But then this is Arun. Is this his name? I'm trying to remember. Yeah. Anyway, it'll come. This is right here, the pilot plant. Tomography tracking particle. I think this was with X-rays. Yes. With X-rays, tracking a particle in a cyclone, and then of course now the positron emission particle analyzer in Cape Town, which we've been using now for the last 5 years. It's just celebrated its fifth anniversary, and the most amazing thing about this, you can actually see particles moving around in vessels that you can't look into. And finally, computational modeling. This has gone in the last 20 years. This has gone crazy, and the nice thing is it enables you to come up with models that you can now test the validity of these models using the PEPT, which is fantastic. It's not all good news, as we know. Public perception of the mining industry has probably never been so low these days. Obviously, with deaths on the mines, safety violations, and it's just generally got a very bad reputation of corruption with weak governments and that sort of thing. And you know, these sort of pictures don't help when you get these slime dams in Brazil bursting and causing loss of life. You have spontaneous combustion, acid mine drainage, and then this tragedy at Maracana. where the police shot 30-odd people. It doesn't do the mining industry any good at all. Obviously, the mining industry is trying to make a comeback. So we have things like the good things like the EITI, which has now been going for a few years, where countries, in fact, join up, where now the government will disclose receipts from mining companies and the companies disclose payments, and this is all audited and trying to make the whole thing more transparent. And then the ICMM now for a number of years has had a sustainability day at the mining indaba in Cape Town, where I was there in 2013, where Mark Kutafani, who's the CEO of Anglo American, said we have to think beyond mining being an extractive industry. We are a development industry. In 2015, the topic was bridging the trust deficit between mining and communities. So I think there is an effort there, and the SMI, I think the work that we're doing in Cape Town, I think it all helps to do this. And obviously the ICMM, I think, is doing fantastic work, but it's 2 steps forward, 1 step back. Don't know what this slide has to do with anything. It just was on Google and it looked great. A lot has changed since 1970. But in fact, if just think about it, that's just a start. I've seen many more things, many more changes in 40 years than this great fellow saw in 100 years, if you think about it. The changes have been remarkable, and just outside of mining, the geopolitical changes that have taken place. For example, this was the period of the end of colonialism. If you had an atlas back in 1970, there were still areas that were pink, that were the British Empire. And now we have countries that are celebrating 50 years of independence. So that's all changed, mostly African countries. Formation of the European Union, these are people who 70 years ago were fighting each other on battlefields. I know they have hassles, but nevertheless, you can breeze into the EU and go anywhere on one passport and with one currency. It's phenomenal. The fall of the Berlin Wall, the end of Soviet communism. One of the reasons that I say I let myself go to seed was that I thought I would be dead by the age of 30. When I was young, I thought nuclear war, that's it. We're all going to be gone. Eat, drink, and make merry, for tomorrow you die. Last, I'm now 65 and I'm a wreck. Anyway, so it hasn't happened yet. The rise of China and India, all we thought about 40 years ago when we talked about those countries was poverty. And look how they're doing now. China is an economic giant. India's, just about there. Global terrorism. These are all big geopolitical changes. Economically, we have multinational corporations. One of the ways to know about multinational corporations that existed back in the 1950s or 60s is get a copy of National Geographic and look through all the beautiful adverts. And you'll soon see that you don't recognize many of those companies because they don't exist anymore. I think of Coca-Cola and not too many others in terms of multinational companies that existed back then. Globalization is where a company like Apple gets little bits and pieces made of their iPhone and then brings it all together. The rise of financial institutions, also some recent phenomenon where the banks have now become so big and powerful and resulted in the GFC in 2008. The changing nature of work. The US Bureau of Mines reckons that by the age of 38, a person in America will have had between 10 and 14 jobs. That's not how it used to be. You used to go and work for somebody and work all your life, and that was it. At the same time, we've seen jobs disappear. We've seen jobs come and the same jobs go. They don't exist anymore. I don't know how many people are formally typists anymore as such. We're all typists now. But in terms of things like farming, in 1900, 90% of the US population were on the land. They were farmers. Now it's 2%. And as we know, jobs are disappearing all the time. And then finally, it's a cyclical phenomenon, but it's a recent phenomenon as well, inequality of income. From the 1970s, as we all know, there have been greater and greater inequalities of income. I had it written down somewhere. I don't know if I've got it anywhere else. I think I might be coming to it, so maybe I shouldn't jump the gun. Big changes in technology. Obviously, in renewable energy, we had things like, we talked about acid rain back in the 70s, and that's been sorted. But we're at the point now where wind power and solar power actually is economically as attractive as fossil fuel energy. In medicine, how many of us remember that in this period, we had the development of the contraceptive pill. On the other hand, we had IVF. And this changed. Obviously, this changes the way people live. This changes people's lifestyles. We've eradicated polio. We've determined the human genome. Simple things like TV. In 1970, it was going to be 5 more years before South Africa got television. When I went to England in '75 and I sat and watched live cricket, Lilly and Thompson bowling at the English. It was just phenomenal. I couldn't believe it. Now you can sit there and watch something, like Roland Garros. We take it for granted. We can go to our TV and watch something happening right now. We expect it to be the case. But that wasn't like that always. And then the internet. What can one say about the internet? I first heard about the internet in this room from somebody called Jane Wilson from the Prentice Center on the 9th of the 9th, 94. It was growing at 10% a month. Presently, there are 2.5 million computers on the internet. Nobody controls it. That's the best part. Or supervises it. No rules. That was 1994. Nowadays, there are 1.2 trillion searches on Google every year. So that's a change. And the other thing is artificial intelligence. And I wouldn't believe in my lifetime that I would have seen a computer or software program actually beating a human being, grandmaster, in Go. Because as our dear friend Stephen Gay would say, chess is trivial, like Go is something else. And it is, because there are more combinations in Go than I think there are atoms in the universe, or atoms on Earth. And yet, 20 years after Deep Blue beat Kasparov in chess, we have this amazing thing that AlphaGo beat Lee Sedol 4-1 in Go, which is phenomenal, because this computer taught itself how to play Go by playing zillions and zillions of games against itself, and learned how to do this. And this is amazing in terms of who we are and where we go. Climate changes. Well, we know about climate change. Be aware of the significant weather event coming tomorrow. The world is getting warmer. Obviously, there are heat waves, more frequent and longer. We have great periods where the temperature is very high. We have less rainfall in some places. The sea levels go up. And the sea is becoming more acidic. All of those things happening, which is new. Social changes. I don't know how many of you are familiar with the Whole Earth Catalogue. Anybody know the Whole Earth Catalogue? Something that came out in 1968. This was the first time that we had seen a picture of the Earth from somewhere else, from outer space. I mean, this is obviously from Apollo 11, I think. It's just phenomenal. It's the first time, and I think this made us think differently about ourselves and about the human family and about being, the global village, about being on Earth. And in fact, in the last 40 years, as far as I know, there have been a lot of things that humanity has done together, collaboratively. I talked about well, I don't know what I talked about, I forgot. The ozone layer, the Large Hadron Collider, the SKA, the International Space Station. This is people that supposedly were fighting a Cold War, still managed to get into the same space station and shake hands. Ebola, and the response to tragedies. Whenever there's an earthquake or whatever, the response is universal. And if you remember, I don't know how many people watched the Chilean miners being rescued a few years ago. That was a phenomenal thing, and everybody in the world was interested. So the social things up there have changed in terms of thinking of ourselves as a global village. The gender roles have changed completely in the last 45 years. It's women in the workforce. There's just so many things have changed. The end of Christendom, the power of the churches over the individuals in the pews has definitely come to an end. I'm not saying it's the end of Christianity, but Christendom. And anybody who watches that series called Call the Midwife, you'll know what I'm talking about. At the same time, we have Brave New World and 1984. So we've got constant surveillance. I mean, I'm a bit peeved that I can't pick my nose in public without somebody seeing it somewhere else in the world. And Brave New World, we have designer babies. This is all happening. Of course, we all know about social networking. This is another massive phenomenon, social networking. So it's quite funny. You go into the internet and you'll see a whole series of pictures like this. If Facebook were a country, it would be the world's 4th biggest. third biggest, second biggest, now it's the world's biggest. There are 1.4 million people on Facebook. If that was a country, it would be the world's biggest country. I think there are 4.5 billion likes every day. We're obviously a nice bunch of people. So, what's changed most of all is the rate of change. Things have just got faster and faster and faster. We're sort of over here, okay? So we can see that things have changed. The thing is that I think in the next little while, it's going to go like that. And so to all the dozens of young people whom I hope to be sitting here and who are not, you know, you've got a massive future to look forward to. Look at this, the rate of adoption. This is the rate of change. To reach a market audience of 50 million, it took radio 38 years, TV 13, the internet 4, iPod 3, and a Facebook 2. You know, that's big it. There are 8 zettabytes of information were produced, new information were produced in 2015, which is more than in the last 5,000 years. 1 week of the New York Times has more information than a person would come across in a lifetime in the 18th century. We've got all this massive data. So much data has been generated, I mean, to the point where who's going to interpret it? But it's certainly an age of information. One of the problems is to do with education, because we're preparing for students for jobs that don't exist, who will need to make use of technologies that haven't been invented to solve problems that we don't even know exist. So, good luck. I'm glad I'm out. Nevertheless, this is part of what's called the law of accelerating returns, where it's been said by this chap Ray Kurzweil, who writes a lot on artificial intelligence, that more advanced societies have the ability to progress at a faster rate than less advanced societies because they're more advanced. Advanced here means knowledge and technology. The 21st century will achieve 1,000 times the progress of the 20th century. Well, at the moment, I'm happy to believe it, because from what I've seen, anything is possible. And yeah, Back to the Future got it so wrong. Back to the Future celebrated its 30th anniversary last year, sometime in October. And Back to the Future, Michael J. Fox went from 1985 to 2015. And I mean, if you saw what they predicted would happen in 2015, it was ridiculous compared to what's actually happening in 2015. They could, it was just amazing. It's really hard to predict. So the question is, what's next? And this is why, it actually quite piques me. I'm really quite tickled to think about these things, and I do think about them. And I'm quite horrified that I've got kids who don't think about the future, because, you know, they're moving into it, and it's going to affect them, and they should be thinking about these things. It's very difficult, obviously, to predict the future. Poets and artists get it most right. And I like that quote from Arthur C. Clarke. He was the one who wrote 2001: A Space Odyssey. Which, by the way, was more closer to future prediction than anything else. New technology-shaped realities will be indistinguishable from magic. And the sage Al Gore said, the emergence of a completely new reality with which we human beings must come to grips. So we're going to have a completely new reality. A wise man, Mr. Peter Munro from MIM, gave a seminar in this room, 14th of the 10th, 94, saying nowadays projects are undertaken that even 20 years ago would have been impossible to contemplate. And he was talking about MacArthur River treating -8 micron material. This is what I liked what he said. To say that we are going to do it rather than have it happen, that is the change. To say that we're going to do it and rather than just have it happen. And now, I mean, these are luminaries whom we know about. You know, Steve Jobs is no longer with us. Bill Gates, Elon Musk. These are people who said, we're going to do this, and they made it happen. You know, and that's the difference. So can we actually ask ourselves, like, what's in the future? Babies born today will be immortal. Somebody said that to me somebody said that there was their first statement in a keynote address I went to at the SME, and that got my attention. So I'm glad that you're all awake now. Nanotechnology. Now, I can't profess that I know about these things, and these are just things that I'm throwing out there as being what's in the future, things that I'd like to think about. I mean, nanotechnology has been around for a long time. But, I mean, when you think about it, it's manipulating matter that's between 1 and 100 nanometers in size, which is just like 10 times bigger than an atom. It's phenomenal. You know, there are many, many applications. You probably know many more of them than I do, but for example, in construction, make buildings stronger, to make concrete stronger, to make the buildings more energy efficient, which obviously then saves energy and has all those downstream effects. There's a new Australian Institute for Nanoscience and Technology that's just been established at the University of Sydney, just like a month ago. They have a gel in the walls, apparently, that allows the building to be thermostatically controlled and to absorb energy. Richard Feynman said, who's obviously the physicist, it should be possible to synthesize any substance by maneuvering individual atoms. Well, that's quite something. And we're getting there. The circular economy. This is something else that I think will happen. The end of unprecedented consumption. There's so much rubbish that you find when you go to the shops. And yet I think we're getting to the point where we're getting, as we say in South Africa, cutful. We get up to here with it. Self-storage in America is a $2.4 billion a year industry. We buy things and we use them once or twice a year. And so the way forward is reduce, reuse, recycle, but even in a bigger way than we even think about. For example, recently there's a BBC program, car batteries, which are no longer good for our cars, but they're fine for example, charging your mobile phone. There's a company in Holland that takes mobile phones apart and recovers the minerals out of them. Marks and Spencer's, this is not just some local corner shop, this is Marks and Spencer's collect clothes. You take your clothes back to them and they take your clothes and they make new fabric out of it, or a car seat. They give you a voucher when you take your clothing back. Your voucher for your next purchase. The next time you buy a shirt, you get a £5 discount or whatever. We're moving towards an era of access, not ownership. It's partly arrived, and it's getting more and more. I've got a stack of DVDs. My kids look at me and think like, where did you crawl out of? We just use Netflix. We don't have to have these things. We just, whenever we want to, we can just access them. Airbnb in terms of accommodation. BMW runs a car sharing service worldwide, 50,000 members, where if you're part of this, you've got a key, you go along, it tells you, on your phone, tells you where the car is if you want one, you pick it up, you drop it off. It's amazing. Like we have bicycles, those yellow bicycles. But here, design is important because the whole point is also to save energy and reduce waste. So the circular economy is going to need that too. I haven't got time to go through this. But the interesting thing is that Markus Reuter, whom we know, who's now the director of the Helmholtz Institute for Resource Technology in Germany, also he's a visiting professor at Melbourne, Stellenbosch, or wherever. He's got this, he's written this book, Handbook of Recycling, or co-written it, where in the mining industry, the same circular economy applies, where we have the ore, we produce products, they go into the market. When they're used, they get dismantled, they get collected, they're physically reseparated again. Again, I don't know what this is, multi-recyclable grades, whatever. Obviously, the stuff that's good enough, you then goes back again, you recover whatever you can, and it goes back into the process, and you make another product, you go. The whole idea is to try and reduce the losses, because as we know, thermodynamically, you have losses. The whole process, you try and get smarter and smarter, and try and reduce the losses. Robotics. This is also an area where things are happening already, but I think this is going to get even more. We think of robots as these sort of things, but a robot is a mechanical or virtual artificial agent that is guided by a computer program or electronic circuitry. And so, for example, I haven't done this, but those of you who have iPhones, apparently, and I've seen my daughter do this, you talk into this thing and you say, tell me how to do this, or take me there, or whatever. And it does. That's a robot. And that will also get more and more. There will be 10 million self-driving cars worldwide. Again, tell me about a self-driving car, and I think you're nuts. And yet, if you actually look, these things have done hundreds of thousands of miles already. 75 billion devices are estimated to be connected to Internet of Things by 2020. There is a mill, apparently, that I read about last week, a mill in Chile, which is now connected to the Internet of Things, and that's going to be run remotely. According to the economic report from the President of the USA, 83% chance that a worker earning less than $20 an hour in 2010 will lose their job to a machine. And it's 31% chance if you're earning $40 an hour, which is, something to think about. Computers are learning for themselves. this now gets into artificial intelligence, which is just further down the line from robotics. Computers are learning for themselves. By 2050, a $1,000 computer will have the computational capacity exceeding that of the whole human race. Now, that is something to think about. And if you're young and you've got a future ahead of you, like some of us don't, it's something that would it would make me stop and think. What does this mean for people, for jobs? Will people have jobs? And so the next thing is, what about a new democracy? How are people going to live? How are people going to work together? Interesting that ChemEng in South Africa back in the early 90s had this high road, low road scenario in terms of getting from apartheid to post-apartheid, which is one of the things that actually got us through that period, civilly. Well, the low road is where your elites retire into gilded cages. And by the way, talk about elite, to be in the top 1% in the world by income, you have to earn more than $32,000 a year. And then you're in the top percent. You're earning more than 99% of the people in this world. Okay, so when you talk about the 1%, just stop and think, where are you in there? So, at the moment, we're already seeing refugees, all over the world, people clamoring to be let in. There's a fantastic TED talk, a billionaire, American billionaire, talking about, we've got to do something, otherwise the people with pitchforks will be at the gates. Will we have a new French Revolution? That's the low road. The high road is we share the benefits. There's a minimum wage, high. This is what Bernie Sanders is talking about in the US. A universal guaranteed basic income, which sounds nuts. But yesterday, just as I was putting this together, yesterday on The Conversation, there's an article, could the idea of a universal basic income work in Australia? Where every child, woman and man in a country gets a certain amount of money every month just because you're human. Just to say, go and spend it. Go and actually create a demand so that somebody else has a job to make something and sell you that thing back. It might sound loony, but it's starting in Finland. And Canada is looking at it, and Switzerland is having a referendum on it. And I believe there's a town, Utrecht, in the Netherlands, is trying to start this up. So it's not crazy. It's actually something which is happening. $3 billion a year Centrelink spends on dispersing grants in this country. That's a lot of money that could just be dished out without worrying about, what your problems are. But this will also require collaboration between manufacturers and consumers or stakeholders. For example, like we talk about corporate social responsibility in the mining industry, for the manufacturers to make things that consumers want. Finally, the promise or threat of artificial intelligence. Deep learning leads to artificial superintelligence. So that, as I said, in X years' time, the computers will be faster, but they'll also be smarter. Okay, because of neural networks, because they're learning like we learn. Through these things zapping around in our brains. They're learning the way we learn. But because it's faster, as soon as it becomes smarter, it'll become super smart, super fast. It's like the pond, that doubles the lilies every day. The second last day, it's half covered. The last day, it's fully covered. So it starts off slow and then it goes crazy. We don't know what artificial superintelligence is going to do when it takes off. Who will control it? And people in the know, it could be with us by 2045. Which is not that long ago. There's even a remote chance that I might even be around. Maybe. I'll be 94. But maybe. Many of the world's smartest thinkers, people like Bill Gates, Stephen Hawking, Elon Musk, think ASI is an existential risk, which means it could wipe out humanity from the planet. Okay, it's a bit scary. So it could actually take over the whole world, and that's it. It could be the end of humanity in 50 years' time. And if I was young, I would want to think about this, On the other hand, it could allow us to be immortal, which is why the baby thing. Nothing in biology is yet found that indicates the inevitability of death. Could we have nanobots running around in our bloodstreams, fixing cells, repairing us as we live? In which case, time will pass, but we won't age. And that's phenomenal. We old-timers, those of us who've got white everywhere, might be the last generation of humans that has to die. It's a bit sad, but there you go. But surely it's something worth thinking about. To wrap up, I've seen more changes, I think, in 40 years since graduating than that old Greek saw in 100 years. But I don't think I've seen anything compared with what's to come. So yeah, the future is going to be a roller coaster. Please think about it and be prepared. So, acknowledgement and